Okay, for this question, circular motion. Okay, circular motion, you need to remember that the main thing is always on centripetal force, okay, which is a resultant force. So here the details is given to you that this is 0.2 meters, but they did not give you anything for RB except that 1.3 and 4.1. So let's solve A part 1. A part 1 is pretty simple. We'll be using the formula V equals to R omega. So omega is V over R, which is 1.3 divided by 0.2. Okay, so it's the same as 13 over 2, which is 6.5 radians per second. Okay, part 2. Now they tell you that it's a constant angular velocity that happens for the entire table. So A and B will both have the same angular velocity. Okay, just that the speed, the velocity is different because their distance from the center is different. So for B, right, we can actually use, I mean, we'll be, frictional force is actually providing the centripetal force, and we can actually use the formulas for centripetal force, mv square over r, or mr omega square. But you realize that they need r here, so you can find r by taking v equals r omega again. But you could also use mv omega. Okay, that's the third equation. So all these three equations are equation for centripetal force. So first thing we need to write in your answer that the frictional force, you need to show why frictional force is equals to the centripetal force. So frictional force provides the centripetal force for B to move in a circular motion. So because frictional force is this, so you need to calculate the frictional force. Therefore, the frictional force equals the centripetal force, which is equals to mv omega. Okay, m given to you 10 gram, v 4.1, omega 6.1, 6.5. Okay, 4.1, 6.5. So just key into your calculator. 0.01 times 6 times 4.1 times 6.5, you get 0.2665 Newton. Okay, I put more SF in the intermediate step. Then we look at what they give. The raw data is all 2 SF, 0.20, 1.3, 4.1. So approximately 0.27 newtons. Okay, part B. Figure 7.2 shows a car that's traveling at constant linear speed. It tells this is a bank road. So draw and label all forces acting on the car. This is pretty simple. So you will, is there friction? Just check. There's no friction. So no friction will just be the normal contact force. Okay, need to write down normal contact force. You also need to write down the weight of the car. So these are the only two forces acting on the car. Okay. So calculate the linear speed. Now it is moving in a circular motion. So to calculate circular motion, right, your first thing is to always identify the center of the circle, which in this case is here. So it's telling you that the resultant force is towards this center of the circle, is horizontal. Okay, and as per dynamics question, what we'll need to do is to resolve our forces perpendicular and parallel to the direction of acceleration. Okay, so for this particular scenario, okay, let me just redraw the forces again. So you have your weight that is downwards, and then you have your normal contact force that is slanted. Okay, we know that it's going to be 15 degrees here. It's 15 degrees here. And we know that, okay, let me just change the colors a little bit so that it's clearer. We know that this here is going to be 15 as well. Okay, so this is 15, this is 15. So we can actually get it that the vertical component here is n cosine 15. And the horizontal component is n sine 15. Okay, now there is no movement, no acceleration in the vertical direction. So we can say that n cosine 15, which the upwards direction, is equals to mg, the weight. We also can say that n sine 15, which is the resultant, okay, that's what gives us our centripetal force, will be mv square over r. Okay, I chose mv square over r instead of mr omega square because they gave speed, or they are supposed to find speed, and they gave you radius. Okay, so from here you can see that n is not given. That's why we need these two equations. So let this be equation 1, let this be equation 2. You could actually find n from equation 1 first and sub into equation 2. Or you can just take 2 divided by 1 to get rid of the n. So you'll get tangent 15 degrees equals to v square over gr. So v square equals to gr tangent 15. Okay, g is 9.81. R is given to you as 20 meters. Okay, so 9.81 times 20 times tangent 15. Okay, I'll just square root directly. Okay, you can just find with your calculator. You should get 7.25 meters per second. Okay, that's for the linear speed. Now left with part 2, B part 2. Given that the car now travels at a faster speed, state if a reason whether it will move up or down the road. Okay, now with a faster speed, what will happen? The faster speed means that the centripetal force required is larger. Okay, so let me just type this out. With a faster speed, the centripetal force required is larger. However, the normal contact force and weight remains the same in magnitude. Okay, required doesn't mean the magnitude will change. Okay, the magnitude will still be the same. It remains the same in magnitude. Hence, the horizontal component of the normal contact force is insufficient to provide the necessary centripetal force. And the car will move up the road. Okay, move up means go further away. Okay, it's like being thrown outwards.